Hi, it's Jan Beta, and we are back here with the Commodore 16, one of the ones that I repaired in one of the previous videos that I'm going to link in the corner there. As I said in that video, I am going to refurbish and restaurate and future-proof one of them, which is this one, today. As you can see, this is a fully working Commodore 16. I did some testing on it and it appears to be fine. So what I'm going to do today is to clean it up. It has some dust and grime in the... It's not that bad actually, but I'm going to clean all the keys, clean the case. I'm going to replace the key here, and I'm also going to add heat sinks to the main ICs. I think these three, the PLA, the processor, and the TED chip, which is the combined graphics and sound chip, these get incredibly hot. That's why they fail so often. I'm going to put heat sinks on these and replace the electrolytic capacitors, and I think I want to replace the little voltage regulator there, which is a 7805 5 volts regulator. So that's the plan for today. The first thing I want to do is, of course, take this all out of the case to be able to work on it. The very first thing, of course, is to turn it off and unplug it. So the case, I opened this previously. There is 3 screws basically that you have to unscrew to open this up, and then there's these 2 connectors, one for the LED and one for the keyboard that you have to remove. And then you can take off the whole top part here. And this is held in by a couple of screws. There's a screw that's not original in there. Probably going to replace that. And I'm going to use my anti-static wrist strap here to not accidentally zap these specialized chips that are in there. Because they are pretty expensive. Because they fail so frequently. Okay, board's out. Let's take the keyboard out of the case so we can wash the case basically. So for the keyboard you have to remove the screws around the perimeter. There's a screw missing as well. So this one has been tinkered with, I think, but it's not in very bad condition. Not at all. It's in very good condition actually. Except for the key missing, but we're going to take care of that. So there's our keyboard, nice. And for the LED you just lift, there's like a ring around the LED assembly that you lift off with a screwdriver or something. So you lift the ring. Isn't that easy actually? There we are. Okay. There's a ring. Then you can just push it through, I guess. Yep. There we go. And don't lose the ring, because that locks it in place. Okay, removing this, and then the case just goes into some soapy water. So this just goes into the shower with a brush and some Sillet Bang for floors. And I use like lukewarm water. So now I'm just leaving this to dry for a while and get back to the electronics part. Let's go! So let's go on with the capacitor replacement. I'm replacing the electrolytic capacitors because these components do age. Usually they are still good in these units, but as I call this future-proofing, in the future they are going to eventually fail. In this case, probably the ICs are going to fail before, but yeah. It doesn't hurt to replace them if you are good with the soldering iron and have some capacitors. These are I think these are all 10 microfarad, 50 volts ones, one 1 microfarad one, and one 47 microfarad one. So it's pretty straightforward on this machine, and it doesn't hurt to replace them. I'm also going to replace the voltage regulator, but that's going to be later. For the replacement caps, I use Panasonic FC type, which are, in my experience, they are pretty reliable general purpose capacitors that I always have in stock. I think for the 1 microfarad one, I have a Nichicon or something. Always go with the good brand caps like Nichicon, Rubicon, Nippon Chemicon, Panasonic, and there's more good brands I can't think of right now, but yeah. These are, it's not very important which type of capacitor you use, just go for the exact same capacitance and go for a voltage that is the same or higher, but not go too high because the characteristics of the capacitors are going to change with the voltage that it is rated for. Always go for 105 degrees Celsius rated capacitors. That's what I do. These are usually rated for 85 degrees Celsius, so they have a longer lifespan if you take the 105 degrees Celsius rated ones. So, what else to say? I always do one at a time so I don't get the values confused. And yeah, just go about the whole board with my desoldering station and my soldering iron. And yeah, be very careful with these old boards because sometimes they are pretty brittle and the traces or the pads lift easily if you are going with too high temperatures. I usually use like 350 degrees on both my soldering iron and my desoldering station. You have to, your mileage may vary, it's a bit of a personal preference thing, but I usually go with 350 degrees Celsius, which works fine for me. If you have problems desoldering, add a bit of fresh solder or a bit of flux to the solder joints, and that will make it easier. Usually, in my experience, on these mid-80s boards from Commodore, desoldering is pretty easy. There are much worse boards. The earlier boards are much worse quality, so you easily break off pads. The later boards are difficult to solder because they have larger ground planes and stuff like that, so the heat is going to be sucked away by those. Okay, that's all I can think of right now. Let's just go on and recap this. Okay, all recapped. It wasn't too bad. This one was a bit stubborn because it has this large ground plane connected to it. And the 47, this is the 1 microfarad one, the 47 microfarad. I was told that farad actually comes from Faraday, so farad is the right way to pronounce it. In Germany we say farad or farad. That's actually wrong, so I'm just trying to say farad from now on, which is the correct way. I said farad before. So, farad. This is the 47 microfarad one. That was also connected to a large ground plane. It's a double-sided board, by the way. The ground planes are, there's a portion of ground on the top side and there's some grounds on the bottom side as well. And as soon as a component is soldered to one of those, a lot of heat dissipates through the copper in the ground plane. so you have to use more heat. In my case I used like a bit of solder wick and added some solder and used my soldering iron to suck out the remaining solder there. So it was a bit stubborn, but it's okay. Just don't lose your patience, and sometimes you have to be quite patient. Add some solder and suck it out. You can also use the solder sucker, and you can of course use the desoldering station, just put it into a higher temperature or something like that. In this case I got away with just using my soldering iron and a bit of patience. So next thing I want to replace is this voltage regulator, which is a standard 7805 rated for 1 amp or maybe 1.5 amps, I'm not quite sure. I am going to use the 78S05, which is rated for 2 amperes, which might be a bit of a problem in case you need the internal safety circuitry in there. It has a rudimentary overvoltage and short circuit protection and a temperature protection, I think, so that is going to go off like 0.5 amps higher than with this one. So that might be a problem. I have not experienced any problems with that, but if you are not sure about that, you want to use a standard 7805. I am using 78S05 because I have them and have had good experience with replacing the C64 7805s with those. This one doesn't have a rectifier because the power supply supplies DC voltage, so it doesn't need a rectifier circuit, and it doesn't need like large filter capacitors like the C64 does. Quite a nice touch, actually. And this is attached to the heatsink there with the screw, so we're just going to have to lift the screw and hold the nut on the other side. So the glue is pretty hefty here. Okay, there we go. Hey! So I misplaced my spray can with isopropyl alcohol that I usually use for stuff like this, so I'm just going to improvise a bit. At least I found my Q-tips, so I'm removing the old heatsink plaster here. Okay, 78S05, here we are. So usually what I do is to put them in here and just eyeball how they are supposed to bend. And I'm going to add some heatsink plaster, and then I'm going to screw it down. I should really wear my wrist strap because these are semiconductors and they are pretty yeah, these are pretty robust, but in general you want to be careful. So there we go. Bit of standard heatsink plaster, not the stuff for CPUs and modern stuff, but the standard one for transistors and like these voltage regulators. You can of course use your PC heatsink stuff as well if you have that handy. And usually I end up messing this up a bit. Where's my screw? There, it's still connected to the screwdriver. So, nicely screwed down. Yeah, that's basically it. Now for the heat sinks. And of course I have to solder this in. I nearly forgot that. Soldering it down after screwing it in, so I don't stress the solder joints too much. Okay, cutting the leads a bit. There we are. New voltage regulator in place. For heat sinking these, I'm using these, which are, I think they are sold as VGA coolers. I got these off eBay, I'm going to link that in below. And I think they are available elsewhere. They have like this profile and fit on the chips, so they are approximately 1 centimeter wide and 1 point something in the other direction. And they have 3M thermally conductive double-sided tape on them. So I'm going to put some on here and some on here and some on here, because this is the processor, this is the TED, this is the PLA. They get warm. The other ones are ROMs. These are logic chips and RAM. They don't get that warm. This is like the I/O chip. It doesn't get that warm, and usually these are not failing. Maybe the RAM is failing, but that's not because of the heat cycling usually, but for other reasons, because it's not very well made. So one other thing to take care of in these machines is there's a lot of standing components on the board, and you want to make sure that they all are standing upright, so they don't short out with anything. So they might short out with the shielding if you have it still installed. I removed that. Or they might short out with other components, and of course you don't want that. So carefully take a look around and see which components might be shorting against each other. That's a common point of failure actually with these. So what I'm going to do is to clean the surfaces of the chips with some IPA and a cotton swab, or an Q-tip, whatever you want to call it. Then attach the heat sinks to them. And then the most important part is the middle part, because that's where the die is in the chip and the heat is generated, but usually the whole surface gets warm, so I'm adding like a couple of those, about as many as I can fit on there. You can of course use like heat sinks that are in one piece. There are correct sizes for all the chips that you can just attach on there with some thermally conductive glue, basically heatsink plaster. I don't have enough of those, so I am going to order some, because they are better because they have a larger surface area. And these you have to rely on that the heat spreads out between them. There are little gaps usually, so it won't the heat won't transfer from one to the other, so you basically are cooling individual spots of the chips, which isn't ideal, of course. So I'd rather go and have whole pieces, but I don't have them, so I'm going to use these, which I have in the past for my C64s and other stuff, and it works fine. So still recommend these, but I'm going to get some larger ones in the future. Okay, there we go. Heat sinks are added. Let's test if this still works at all. Yep. Still works. Nice. So I kind of want to have a look at the RF modulator too, which I did on the Commodore 64s. I don't know if the output signal is generated in here as well, but on the C64 it usually gives an improvement in picture quality, at least from the composite output, if you recap the RF modulator. So I'm just going to try that on the C16 as well. So I'm going to desolder this. I think it's soldered on from the backside here, yes. And then I'm going to look inside there and see if I can replace any caps. I could actually think I can look inside without removing it. Let's see. Yes, I can. And there's 2 little caps in there. Okay, so I'm going to desolder it and replace the 2 little capacitors in there. So here we are. Bottom side should come off after I desolder this spot, and there's another spot on the front there for grounding it. Well, this gets hot. Of course, obviously. So you have to wait a bit before you can touch it again. Yeah. There we go. Okay, that wasn't too bad. There's a lot of smaller surface mount components actually on the bottom. Not too bad for 1984. So let's replace the capacitors. This one. "10 microfarads, 16 volts. Low profile. Hopefully we can fit this in there. Yeah, if we bend it to the side, it's going to work. Ideally you would of course use a low profile one. So I won't recommend this. This is just for for science basically. Just testing if this does any good. So I don't recommend you recap your RF modulator. But I just did. Let's see if that helped any. Proper future proofing. Okay, let's attach this. And back in the board it goes. And of course I forgot one crucial thing that I always do when future proofing. I sign the work. If I remove the RF modulator, I sign it beneath the RF modulator. So I have to remove the previous, I don't know, repair person's, like probably factory person's sign here. One more test. Yep, and it still works, and the picture quality looks the same actually. So you don't really have to recap the RF modulator. I guess if you used RF output it might improve the picture quality, but who uses RF anyway? So nice, this is technically now future-proofed in the sense that it is probably going to live a bit longer than it would have with the without the heat sinks especially, and without the new capacitors and without the new voltage regulator. So that's that's about all you can do for these. You could go further and replace the ROMs with EPROMs that get less hot. These get moderately warm. You can replace the 7805 with like a modern DC to DC converter, which doesn't produce as much heat. There is a large resistor here. I think you could put heat sinks on that as well. And yeah, that's basically it. I think there is a replacement for the PLA. You can use like, I think the super PLA that individual computers made is has a mode where it replaces this PLA as well. There's other replacement PLAs for this available, I think, but usually these are less prone to failure than the PLA and the C64 actually. So yeah, this is the technical side of things. Let's see about the keyboard. Oh, and what I always do is to clean up the bottom side of the board with some IPA to remove the flux basically. And there's a lot of flux that's still there from factory basically on the parts here, which you also can clean off with a generous amount of IPA. Usually. And then we have a much cleaner board ideally. So, for the keyboard, I want to remove all the keys anyway, the keycaps at one point, but at first I have the keycap for the 9 that is missing, but it's missing the stem that's really coming out there. Let me remove one of those. So, there's a spring and there's a stem, like with a cross on it, underneath. And this one is broken off for the 9 key. And I want to replace that. So what I have to do is to remove this bottom plate here. There's a lot of screws that I have to remove, but then you can basically take off the bottom plate. You have to desolder the shift lock key. There's 2 wires coming from that. And then you can remove the whole bottom plate, which has the PCB, and we can give that a clean, which is also a good idea. And replace the stem with one from this strange spares keyboard that I got ages ago. This is like a Commodore 64C that has the... I believe it's just the keycaps from the C16, but it has to be compatible with the C16. Actually, maybe I'm just going to use the 9 key from this one, because mine has broken off piece in the keycap as well. So we're going to see about that. First of all, I have to remove this to get access to the plungers that are... This one is broken. So now we should be able to take this whole thing off, which we are. And I prefer doing this while the keycaps are still on, otherwise you would have the plungers fall out if you turn it around. So we only want the plungers, which are these ones you can see here, which have like 2 conductive pads each. And we don't want those to fall out. We only want the one out that's broken off. So let's see. So now we of course have 2 coming out. And this is also kind of missing the conductive pad here, so that would have to go anyway. So now we have to do the same thing over again for the other keyboard, so we can remove a plunger there. And this has a screw inserted as a fix. So somebody had some thoughts about this, but it didn't really work out. The key broke off again. Yeah, need a key from the other keyboard. So let's remove more screws. So they appear to be the same, but actually I think this is our C16 keyboard, and this is our C64 keyboard. The matrix is slightly different, as you can see. So there's like 2 lines here, and there's a whole bit. This is the C64 version, and this is the C16 version. We just want 1 key, so let's remove 1 key from this one. It's the 9 key. Let's just take the whole key, I think, because these are... Let's take the whole key with everything and the plunger. Just putting this back in here. We should now be able to just place the key here. There we go. Okay, that was an easy fix. Except for having to remove a lot of screws. So I'm going to put this together properly again. The spares keyboard thing just stays the spares keyboard, I guess. So yeah, I want to clean the PCB for this and then put it back on. And I I think what I want to do is to remove all the keycaps afterwards, so the plungers won't fall out, and then I'm going to clean the keycaps. So that's the plan for now. So for cleaning this, I'm just going to use a microfiber cloth and some contact cleaner that worked pretty well for me in the past. Just going to lightly spray this and spread it around, because you don't want to damage the pads. These little pads are actually carbon, like a lacquer, and you can easily rub it off with alcohol and stuff, so I'm very careful with these and usually just go over very lightly. I cleaned these with alcohol without problems, but only go very lightly and don't start scrubbing too much. And this is pretty clean, so I'm just going to go with a little light coat of contact cleaner on these, and I'm going to put it back on the keyboard. Which means a lot more screws! Yay, screws! This looks pretty clean, so I'm not going to do anything about that. Now I'm going to remove all the keycaps using my keycap puller. Highly recommend getting one of those because it makes damaging the keycaps much more unlikely. I won't say it's impossible, but I went on and just lifted them up with the screwdriver, and that didn't work too well. I messed up one or two keycaps doing that. So ever since I have this thing, which just grips the key from two sides, you can just pull straight off. I don't have any problems with damaging keycaps. Fingers crossed that it remains so. Don't know if I should do slight retro brighting on these, because they are very, very subtly yellow. I don't think so. I want to clean them and see if that helps. So let me just remove all these keycaps, and I'll be right back. The spacebar has kind of a metal frame that is clipped into the keyboard here. So there's in the middle, there's one of those plungers like normal. You can see it here slightly. You have to lift these out of the board, which I usually do by pushing them slightly with a screwdriver. They come out to the front. So there we go. So these get some soapy water, these just stay. This gets cleaned with a toothbrush and some IPA, I guess. So the case turned out pretty nicely. There's some scuff marks here and there, But overall it looks really nice and much cleaner than before. That was the intention of washing it, of course. And the keys nearly look as good as new. There's no yellowing that I can see. So I think, or maybe there is some very, very, very slight yellowing that I can't see. there definitely would be yellowing after all these years, I guess. But as far as I can see, I can't really see any yellow tint in the gray, and there's no gradients that I can see. So these turned out pretty nicely. It was just dirt. So let's put the keyboard back together, put the keyboard in the case, and put the PCB in the case. Yeah, montage! And because I have it, I can use another C16 as a guide. This little plate here that fell out belongs here, next to the RF modulator. It just covers a hole there that's there for, I think, for a channel switch maybe? This one doesn't have a channel switch. Maybe the NTSC version has one, I don't know. Or they, I don't know, they planned to have one and they didn't in the final version or something like that. Ta-da! Must say, turned out pretty nicely. Let's quickly test if this still works. Yes, it does. Does the keyboard still work? Oh, shift lock's activated. Yay! Okay. It totally, utterly still works. Nice. So luckily Chris, who donated 2 of the C16s I repaired in the last video, also donated quite a bunch of adapters and all kinds of stuff, a dataset and some tapes, including this one, which I cheated and loaded this from my SD to IEC device. Which is Fire End, which is one of my favorite games on the C64. And this version looks a lot better actually, it's a lot more colorful. Yeah, so I call this restoration a success. This machine fully works. I didn't even play. I am going to play some games on my Twitch channel tonight, the day this video is going live. I am going to play some games on this very machine on my Twitch channel tonight from 7 o'clock my time. I'm gonna link that below. So yeah, Hope to see you all there. Hope to see you again on this channel. Thanks for watching. Hope you enjoyed this. Hope this is useful to somebody who wants to restore a C16 as well. As always, thanks very much. Hope to see you again on this channel. I'm Beta. See you next time. Bye.